Welcome to IT Pro TV. I'm your host, Don Pizzette.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus, Building from Source. That's what we're going to do with the help of Don Pizzette. Don, good to see you, sir.
Glad to be back, Zach. And in this episode, we're going to be taking a look at installing software. Now, in earlier episodes, we saw how to install software that was distributed as a RPM or a DEB package using our package managers. But not every application is deployed that way. Many are distributed with just the source code, leaving it up to you to compile it yourself. So in this episode, we're going to get a chance to see that. We'll see how to just take straight up source code written by a developer and turn that into an executable binary. And it might sound a little intimidating. It's actually not that hard. We'll run through that process, and you'll get to learn how to do all that right here.
Well, Don, why should we build an application from source code?
All right. This is a question I get asked pretty frequently because obviously it's a lot easier if you just have an installation package and you install and you're done. If somebody distributes binaries, it is simple. It's even easier if it's in a repository because then you can just automatically install it with Yum or apt or whatever, and you get the application. So that's what people will normally do. But there are a few times where we'll really need to install via source. And I guess it kind of boils down to two things. If you just want to, that's one reason. Or if you have to. There are some applications that are not just deployed or not distributed as a precompiled binary. You don't have a choice. That they just say, here's your source code, you execute it, right? You compile it and run it. And typically that happens when a developer is writing something just for themselves. Maybe they didn't plan on distributing it to the whole world and they just kind of wrote it for themselves, but they decided, I'm going to share the source code. Maybe somebody else will find it useful. But they don't want to bother with compiling it. And one of the main reasons for that is different people have different architecture. You might have a 32-bit CPU or a 64-bit CPU or a PowerPC or an ARM-based CPU. Applications have to be compiled for each and every different processor they're intended to be run on. Well, if the developer just has one processor, they probably don't care about the other types that are out there. And so they're like, well, for me, I need this one. And then if somebody else wants to go different, here's the source code, let them have at it. And so in those scenarios, we might want to install some software, but it's just not compiled. So we have to get in there and do it. Also, compiling software takes time. You're basically taking text that's written in a way that humans are supposed to be able to read, and then it gets converted into a binary that's written the way a computer needs to read it. And the bigger the application, the longer that takes. Compiling something like the Linux kernel can actually take an hour. Bigger applications like OpenOffice, compiling that whole thing can take hours on end, even on a good system. So if something is changing frequently, then it's a pain to get out there and compile over and over and over again. So what a lot of developers will do is they'll set landmarks or milestones in their project, and they'll say, once a month, we're going to compile and put that out as a release, or every 6 months, we're going to compile and put it out as a release. Meanwhile, they're making changes all throughout the middle. And so if you want the latest and greatest from that developer, oftentimes you're going to have to compile it yourself because it's just going to be distributed as source code. And then lastly, the developer in the open source world, a lot of times there's just a single developer, right? So if there's one dev that's dealing with this software, she might not have time to actually go and compile and release that way. So she's just focused on making the software as good as possible. And that's it. And, you've got restraints. So that's another scenario where it would be up to us to actually go and compile it ourselves.
But what if we have both options? I mean, how do we choose?
So it depends on a few things, right? There's pros and cons to either one, right? And I'll tell you, if we're talking about effort, it's way easier just to get a precompiled binary, right? So if a developer is distributing the binary, you just download it, install it, and you're done, right? Versus source code, which is kind of a pain, right? We have to go through a lot of hoops to compile that into a binary. But on the pro side, on the benefit side, right? First off, if you care about security, whenever you get a precompiled binary, you don't really know what's inside of there, right? And everybody talks about how it's open source. You can read the source code. It's right there. But when you get a precompiled binary, you don't know what source code they use to make that binary. So they can be publishing one set of source code. Meanwhile, the binary they're handing out came from a different one, right? And there can be all sorts of junk in there you wouldn't even know about. If you download the source code yourself and compile it, now you know exactly what's in there because you compiled it yourself. So from a security standpoint, that's a big deal. That's a big benefit and one reason why you might Even if there's a binary available, you might still want to compile yourself. Also, performance. Remember how I mentioned software has to be compiled for different processors? A lot of developers will cheat a little bit and they'll try and make a binary that runs on more than one platform. They'll say, this one would be good for 32-bit and 64-bit. And your processor might have SSE2 or SSE3 extensions or VTX, VTD, whatever. We'll kind of make those options possible, or maybe we'll turn those off so it's more compatible with more things. Well, when you compile the software, you can tell it, I want to compile this for a 64-bit CPU with SSE3 and VTD and blah, blah, blah. And it builds a binary that is perfectly tuned for your system. You'll get better performance. Now, it's not going to be life-changing. It's not like it's this huge mega difference, but there's a little bit. And if you're in a high-end like database system where even shaving off a few nanoseconds here and there really starts to add up, then it may be worth it. And there's entire distros like Arch Linux that are built around this idea of compiling everything yourself. It's a pain in the butt, but there is actually a return on it. On the negative side, when you install from a precompiled binary, that developer will usually have a distro. And if there's an update, it's just distributed as new binaries. And so you can run yum update or apt upgrade, and it'll pull down these new updates and you're in business. But when it's source code, there's no way to check that automatically. Every now and then you have to manually go and look, is there new source code? There almost always is. Then you've got to download it, recompile it, put it in place. So updates are a big pain with compiling for source. That's an area where you're better off going with a binary. Mistakes, you can make mistakes, especially when compiling with command line compiler flags. You can screw up all sorts of things. You can actually end up with an application that performs worse if you've tuned it incorrectly. And then lastly, compiling from source requires a compiler. If you're running a minimum install server, it probably doesn't have a compiler on it, which means you've got to compile the source on a different system, which might not have the same processor, might not have the same hardware, so now you're not getting the optimizations out of it. Or you've got to install the compilation tools on the server. So now the server has a bigger attack surface because it has tools on it that you didn't intend. That's an extra hassle. Might be worth it in the long run, but you've got to kind of weigh the benefits on that. For most people, and when I say most, I mean like 99% of the people, installing a precompiled binary is going to be the way to go. But it is an option to compile from source, and there are some times, even for me, where I don't like to do it, there are still a number of scenarios where I find myself compiling from source.
Well, can you give us an example of a program we want to build from source?
Yeah, I can give you a great one. Let me bring up, I've got the web page here. OpenWall has a little program called John the Ripper. And what John the Ripper is designed to do is test password strength. You can give it a library of passwords, and it can run them against user accounts. It's like a brute forcing tool.
Yeah.
So it's a great way to validate that nobody in your company has the password set to 1234, right? Or something silly like that. It can
That's
check
a
for
great password.
It's the same password I use in my luggage. So it's a great way to test for that. Well, if you go to the John the Ripper website, it's openwall.com/John. You'll see on there where they have John the Ripper for Linux and Mac OS and so on. And if I go for Linux, if you click on that one, I see where it's available. It's a precompiled binary, and it's $185 to buy John the Ripper Pro with upgrades. Okay, so $185 to buy the binary. Or, back there on that main page, I can download the source code for free.
Ooh.
So here's an example where if I get the binary, well, I got to pay for it. You get support, there's benefits there. Or I can get the source code for absolutely free if I just compile it myself. Also, this is security software. So if it's running against my user database and validating passwords, do I know if it's reporting back somewhere that I don't necessarily trust? Well, with a precompiled binary, I wouldn't know. I wouldn't have a way to validate that. But with the source code, I can. So there's another great example of where I might choose to pull the source code down and compile from that. So there's a tar file right here that you can download. You've got the source code. Now you just compile it for your system, and off you go. So that's an example right there of one that I've done a number of times before to actually get compiled.
What tools do we need to get started, Don?
The main thing you need, usually you just need one thing, and that's a compiler, right? And way back when Linus Torvalds originally created the Linux kernel, the compiler was one of the first things he had to do. A kernel in an operating system isn't any good unless you can run applications on it. And so he chose to use the GCC or the GNU C compiler. The GNU tools are all laid on top of this Linux kernel anyway. Yeah, yep, GNU. So GCC, the GNU-C compiler, that was the primary compiler that was used back in the early days. Well, today it's still actually one of the main ones. There are a few new ones that are kind of coming along that we'll see more of over the next few years. But at least for right now, GCC is something that we'll need. It might be installed in your system already. It might not. In fact, I have no idea on my system. Let me find out here. I'm going to open up a terminal and just type GCC. Yeah, command not found. So I don't have it on a normal desktop install, on a normal server install. They don't install the developer tools. So you don't have a compiler. So I'm going to need a compiler. Beyond that, that might be all I need, but there'll usually be some other libraries that we need. If I'm compiling a program that uses Telnet, there's probably a Telnet library that I need. Or if it's using IPv6, there's an IPv6 library I might need. My operating system might already have those libraries. In fact, that's really likely. But in some scenarios, they're missing, especially when it comes to things like SSL. If I'm going to be using encryption as a part of the application, I probably need the OpenSSL libraries. And while my system might have OpenSSL as a client set up, it might not have it as a server. And so those are libraries that I would need. Typically, it's going to be the vendor that tells you what you need. So like if I go back to that John the Ripper website, a lot of times they'll have instructions on the requirements. If they don't, you can kind of just do a shot in the dark. You know, you can just try and compile it and it'll fail and tell you, oh, we're missing this. All right, so you put that in. Then you run it again and see if it fails. And you keep doing that until you get it error-free. It's kind of a pain, but that works. Hopefully there's documentation that tells you exactly what dependencies that are out there so that you can have them in place and be able to compile them. Now, in my case, I'm missing GCC, so I need to get that. And every distro that I've touched for the last 20 years has had GCC as part of their default repositories, so you should be able to install it pretty easy. On my system, I'm going to do a sudo yum install GCC. All right, so that's going to go and locate it. There it is, so GCC. It is pulling a few other things down along with it in order to make sure that application will work. I'll just say yes to that. It's a blazing 32 megabytes in size. This is pretty small. But if you're trying to do a minimal server, you're trying to keep that attack footprint really small, that's 32 megabytes of extra binaries that I now have to worry about on my system. But once it's there, now the GCC file is present. If I do a man GCC, here it is, the GNU Project C and C++ compiler, and I can use this to compile applications. Now, I usually won't stop here. There's actually a few other things that are pretty useful to have. There's a utility called make, and the make utility allows you to load a configuration file at compilation time. If you just use GCC by itself, you have to provide a ton of command line arguments. If you look through the help documentation, look at all of these different options that are available inside of it. There are tons and tons and tons, like literally, I believe it exceeds 1,000. There are a ton of command line options. You can't be expected to even know 1% of these. There's so many. And that's really frustrating. So a lot of developers will release a configuration along with their source code that allows you to quickly and easily compile without having to know 10,000 flags. This just keeps going on and on. So if they've done that, it's usually distributed as a make file, and the make utility will allow us to read that and use it and save a ton of time. The other thing is a lot of binaries are compressed, and so we need the gzip utility to be able to manage that. Now, most systems do have the gzip utility, so I see it, I've already got it on mine, but I've kind of gotten of the habit that when I'm going to compile on a system, I usually do yum install or apt install would be the same on the other side, GCC, make, and gzip. Those three right there are kind of my de facto, I need those three. Looks like I already had make and I already had gzip, or make might have been included in GCC already. I don't remember on the packages here. But once I've got those are the tools that we're going to use to do the compile. The only other thing I need is the actual source code. And so I downloaded that right from the OpenWall website. So here it is, this john-1.8.0.tar.gz. In fact, it's archived. So let me extract that. I'm going to use tar. It's tar.gz, which tells me that they use tar, the tape archive utility, to collect all the files together. And then .gz, they use gzip or GNU zip to archive it and compress it. So I'm going to use the tar utility to extract it. And with the command line argument here, I'm doing xvzf. X tells it I want to extract. I want to get files out of it. V tells it to be verbose and show me what's going on. Z tells it that it's zipped and it needs to unzip it before it can untar it. And then F tells it I'm going to give it a file name. And the file name is John-1.8, blah, blah, blah. So when I run that, it's going to extract all the source code, right? Or whatever it is the developer is giving me. And so if I change into that folder and take a look, I don't see a whole lot in here, right? I just see some folders and a README. And that README likely gives me the instructions on how to compile, but I'm going to fly this one off the cuff. There is a folder in here, SRC, and that's where the actual source code is. And if you look in there, I'll see all these .c and .h files. So .c, that's the actual C code that was written, and .h, those are includes. Those usually point to libraries and other things. And so that's all kind of laid out right here. This is the actual application, but I can't do anything with it. Here's a bunch of text files. I've got to compile it and turn it into a binary. And I've got the GCC utility, and I've got the make utility, and they're going to let me do that.
Don, can you run us through the build process real quick?
Yeah, this utility, I had to think about it for a second. This utility is really small, so I can build it here on the show. If I were doing something like the Linux kernel, I could start it, but it'll run for like an hour. This is one case where, you know how most people say they never use but maybe 20% of their CPU power, right? CPUs are usually fairly idle. When you compile something, it pegs out your CPU. It uses 100%. And so the faster your computer is, the faster it can compile. The slower your computer is, the longer it's going to take. Big applications, though, will take a long time, even on a fast computer. This one's small. I think the application ends up being like 2 megabytes or something. It's pretty small. So this one compiles in just a matter of minutes, and so I can run through that. Once you've got your source code unpacked, like I've got mine, so here I am looking at all the source code, assuming that make files were provided, you should be able to, and make files, you can see right here. Here's a make file. And then there's a makefile.dep. Those are the dependencies. So this is a case where the developer did a great job saying, we want to make this easy to compile. If those aren't there, it starts to become a lot more difficult. But if they are there, what you can do is you can run make config, okay? And that tells it that we want to build a configuration for our compiler, for all the compile time flags and things that we need. So I'm going to run make config, and it's going to run, and if I get an error, like here I got an error, it's telling me that it was looking for some kind of an architecture, and I got an error on that one. Let's see, this is where it gets a little tricky. If you look at the config it was building, we got GCC-C-wall-W declaration. All of these do something different. I actually don't know what I don't know what fun roll loops is. Sounds cool.
Or something you eat for breakfast.
But it called the file and it encountered an error inside of it. And so it's telling me about the error inside of params.h, arch.h. It was looking for, and there was a missing directory. So now, just because I don't know what all these tags here mean, doesn't mean we can't figure out what the problem is, right? Looking at it, I see include arch.h, which is our architecture file. It looks like it just doesn't know what kind of architecture I have. And architecture refers to the processor. So do I have a 32-bit or 64-bit or whatever? So I need to get a little more assertive and tell it what I've got. If you just run make by itself, it'll actually give you a list of all the different things that you can compile for all the different systems. And I'm trying to compile for Linux, but you'll see where you can even compile for other operating systems. This goes back to all the work a developer has to do. And what I've got is this guy right here, Linux-x86-64. That's what I'm going to build for. So, and it even said in their little note, like most common. This is what you'll normally build for, which I would have assumed they would have done by default, but apparently not because I'm getting an error. So let's try it again. This time, instead of just running make config or whatever, I'm going to run make clean. I'm using the clean command because I don't know if it did a partial build a minute ago, so I just want to erase anything that was done. And then I'm going to specify the architecture that I want to use. All right. So when I run that, it's going to look at the code. There we go. And it's actually compiling right now. It's going through and reading each of those .c files, including the .h files, and putting it together and building the application. Now, mine's going to run pretty quick, and that's because this is a small program, right? What you just saw, though, could take an hour, could take a full day just running through compiling things, depending on the size and complexity of the application. This one was super fast, though. Now, when it's done, it's not all that spectacular, right? But it is telling me right here, you can see all these temporary files that it was creating and deleting and so on. Somewhere in here, it tells me right here where it actually built the binary. And I can see mine's up one folder in a run folder. I'm in the SRC or the source folder. So if I back up one folder with cd ... and pull up a list, I can see I have a nice shiny new run folder.
Oh, yeah.
And if I go into the run folder, I can see I've got a number of files here that are non-critical, but the one that I care about is this guy right here, John, and it's lit up in green, so I know it's a binary.
Mm-hmm.
And if I execute it, there it is. There's John the Ripper. I see, the command. It's telling me it's version 1.8, and it's giving me all the command line options and stuff that I can run with it. And now it's available. I've actually compiled it. Now, I've compiled it, and it's sitting here in my home directory. And if it's just for me, I could leave it right here, and I can just run it when I need it. But if I want to install it for the entire system for other users to use, there's usually one more step that we need to do. I ran the make command somewhere in here. There we go. But there's actually another make command called make install, which you normally have to sudo. And if you do that, it says take all these individual files and put them where they're supposed to go. If you look, let me scroll back up here to the run folder. If we take a look at everything that's in there, it's not just the binary, right? That John file. There's also john.conf, the configuration file. That might need to go into /etc, which regular users can't write to. You might see man pages in here that need to go into the /user/lib or /man folder. And again, most users can't write there either. So you'll need to do a sudo make install to actually get it to put it where you want it to go. But if it's just an application you're going to run, it's compiled, it's right here, and I can run it. But when version 1.8.1 comes out, I'm not going to know about it. I'm not going to dynamically update. I'll have to go and download the new source code, recompile it, overwrite this binary, and now I'm at 1.8.1. So that's basically the process. It's really not hard, right? Once you execute the commands to run the compilation and it builds it, it pretty much runs itself. It's just different than what we're used to. We're used to just installing a program by clicking on a button, and this is a little more involved.
Excellent. Building from source, another wonderful episode inside the CompTIA Linux Plus series. Hey, Don, anything else you'd like to say?
It's kind of a fun thing to build on your own if you ever get bored and want to do it. The Linux kernel I mentioned is really intimidating because it takes so long to compile, but you can actually get in and build those. If you do like a Google search on self-compiling a kernel, you can build a customized Linux kernel for your system and even get a little bit better performance out of it. But it's a nightmare because the Linux kernel takes so many updates. It's constantly getting updated, and you'd have to constantly recompile for it. But if you're really a glutton for that kind of thing, check out Arch Linux. The Arch Linux distro, they want you to compile everything. And they have a lot of systems and applications in place to make that easier and kind of take away the pain from it. But for everybody else, find a program like this one or somebody that distributes source, mess around with it. Expect to run into some problems like I had that missing architecture file. Expect that kind of thing. Expect dependencies that you'll have to locate. But it's kind of rewarding, though. Once you finally get it to build, you can say, look, I built that from source.
Great. Good advice, Don. And great episode as usual. CompTIA Linux Plus is a wonderful series. It's designed to do one thing, help you now and in the future. So make sure you study, take notes, and seek out supplementary information like what is in our course library. It's there to do one thing, help you be even more successful. So check that out, too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.